Oh. New chapter.
Fields
Yeah.
is the most difficult one.
Where is the image? Hello.
Is that castrating?
It is, it is,
Oh,
it is,
yes,
yeah.
yes.
Where's my picture gone? For goodness sake. Here we go, here we go, here we go, here we go, here we go. Right. Good, good. Electric fields.
Next question start at 5 on the book.
That's a mistake, of course. Alright. Oh, I'm so tired. Went to bed too late.
Be strong.
I'll try. It's hard to be strong. It's easier. You're younger. You can be stronger. Right? What are you drinking? Cappuccino?
Americano.
Americano. Me too. Are you not too hot?
Hot, no.
No? I could open
A
a window.
little.
I could open a window?
It's okay.
Okay. Right, electric fields. So, a few things to do. Not much for the first lesson. So, you know from chemistry, electric charge is a basic property of electrons. So, you've studied electric charge in chemistry. You know electrons and protons have this electric charge. Electrons are negative, protons are positive. And what are neutrons?
They stop.
Neutrons, positive or negative?
Positive.
No,
Negative.
no,
No.
nothing. Yeah. So protons are positive, electrons are negative. Yeah. And I don't think you need to write this down. You know this, don't you, from chemistry? Are you sure you know it?
Yeah.
Okay, good. Right. Things that are negatively charged and things that are positively charged, they pull together, attract. And this makes the electrons and the protons stick together. What happens if they have the same charge?
They push away.
Yeah, they push away. They repel each other. Okay. This is called the law of charges. So positive and positive, repel. Positive, negative, attract. Negative, negative, or that too? Repel. Yeah. I think you also know this from chemistry, but maybe, I don't know, do you know this name, law of charges? You heard of this in chemistry? No? What do you call this in chemistry? You don't call it anything, or?
No, just some basic things.
Yeah, okay. So maybe in your notes you could just write attract and repel, law of charges. Yeah. Got that? Yeah? Okay. So, next. An electric field is a vector field. Now, I first have to explain what a vector field is. I'll give you an example.
Direction.
Yeah, it has direction, good, yeah. And it also has magnitude. So, here's a simple example. If you were to take the wind, okay, this is a wall, and here's you standing, and the wind is blowing like this. But then here, it bends around, yeah? And here maybe there's a little wind. And then maybe here it's bigger. So you can show the force of the wind by using vectors. So here you have a strong force, and here you have a weak force, yeah? And this force points north, and this force points northeast. All the vectors, all of them, that's called a vector field. Do you know this word field? Yeah, yeah. So if you have all these vectors together, you call all of this a vector field. That's the meaning. So I don't know. Do you want to draw this? Do you want to write it? You know, you need some way to remember this word, vector field. It's important in physics. You can write or draw, whatever will help you. I see you're drawing. And you are? Drawing, okay. Yeah? Okay. So, an electric field is a vector field that shows the direction that a very small positively charged particle will move when placed in the field. So I'll give you a picture. So it's important it's a positively charged. Okay, so look. Let's say you have a big positive charge here. Sorry. Yeah, no, big positive charge. And let's say you put a small positive charge here. Which way will it move?
Small.
Yeah, and which way will it move? Yeah, this way. Okay, now, imagine I bring it closer. What will happen? Well, it will move faster, won't it? Like it'll move quickly. So you could draw a bigger vector. So if you try to picture what would happen everywhere, out here you would have small vectors, and then here bigger, and then here biggest. And this is called the electric field. Khalifa, where were you? What's that? Okay, I was waiting for you on Friday. I had your book. Remember I said I'd see you in the office. What happened?
My friends drove my mind here.
Okay. Okay, so I think you can just if you want, you can draw the picture as well, but this is the definition of an electric field.
Only a positively charged.
That's, yeah, the factor, well, the picture is only for if there's a small positive charge put into it. So you can picture then go that if you have a negative charge, then the field will look like this way. Yeah.
But it's still the same, bigger, closed negative charge.
Yeah, sorry, I
outside.
should draw it, and then smaller here, yeah. Okay, do you have that? Yeah, okay. What are you doing in chemistry at the moment?
Isomers and
Okay. Okay. Mm-hmm. Okay, continue. Yeah. So, next. Here is a picture. Now, I've kind of drawn this one, right, I draw something like this a moment ago. So this one here is the field around a minus and a positive, okay? So imagine you have a small positive charge and you put it here. What will happen? It'll be pushed to the left because this is positive, and it'll be pulled to the left because this is negative. So this is very big. Now if I put it here, it will move slowly and then faster in here. And if I put it here, it will move outside. Okay? So this is what the electric field would look like if you have a positive and a negative together. This kind of shape here. In the exam, they sometimes ask you to draw this. And other ones too. So you want to draw this one in your notebook, please.
But what's the line without arrow name? The same?
Which line? We all have arrows.
But it's not connected, like the middle.
Huh?
The line where is the negative.
Huh?
Just the empty line without the arrow. I didn't
Where?
get it. Like this. They all without.
These all have arrows.
They're connected? They're same line?
Oh, same line, yeah. It's curved. Yeah. Oh, I see. Yeah, it's the same line. One line. Yeah. Yeah. Got that? Yeah. Continue. Have you seen this before? No? You have? Okay, good. You've seen it before, Ben? Okay, cool. How do we measure charge? Well, we use a unit called the coulomb to measure charge. And the coulomb is an SI unit, like meter or kilogram. And the definition is quite simple. It's the charge when you have 1 amp for 1 second. So you remember we did amps. So if you have 1 amp for 1 second, then what you'll get is 1 coulomb of charge. Okay, that's the definition of a coulomb. Yeah, so it's a simple definition. Yeah, we never actually, I don't know if I actually gave you the definition, but yeah, we would have used the fact that 1 amp equals 1 coulomb per second. So that means 1 coulomb is 1 amp for a second. Okay. And also, I can tell you what the charge of a proton is. The charge of a proton is that. The charge of an electron is that. It's the same, but with a minus. And the charge of a neutron is that. Now, oh no, not your calculator. Which calculator do you have? Do you have the good one or the bad one?
But he's better.
Yeah, but it's still bad. Because the other calculator, it has this number on it. It has it on it as, oh, by the way, they're the masses, okay? Often that is written simply as E.
Which electron E?
Yeah, not the same E as
Right.
the maths E. But you don't have that calculator. You don't have it on yours. No, so which calculator do you have, please? Okay. Can you write this definition down with these values? You need these values. You got that nearly? Yeah. What you check and go?
Do we have the Coulomb definition? I think we have.
Yeah, you think so? It would be under electricity. That's materials.
Yeah? This
No,
one
no.
isn't.
Oh, you have it? Oh yeah, charging current, yeah. gave it to you already. Good. And it's the same. That's better. Alright, you have those values? Okay, so look. Different parts of the field will be stronger or weaker than other parts. So for example, here, we said earlier that here, this one, there's more force, and here's less. So here this is strong, and here this is weak. Okay. We need a way to measure the strength of the field. So this gives us the idea of electric field strength. So the electric field strength, E, is defined as the force per charge, or as a formula, E equals F over Q. So if this guy has a Q and it has an F, then we say the E is the F over Q. It's how much force you have per charge. Here, it's the same, E equals F over Q. Will this E be bigger or smaller? It'd be smaller. Why? Because the F is smaller. Even though the Q maybe is the same, the F will be smaller out here. Okay. So this tells us how strong or weak the field is. So it's a simple formula, F over Q. Is something confusing you, girl? Oh, my goodness. Sleepy, stayed up too late.
What time?
Like 1 o'clock?
I'm later than you. I sleep at 2:30.
Yeah, but when did you wake up?
Slept 3.
When did you wake up?
10.
Yes, and be quiet. 10.
Quiet.
I had to wake up to get my train at 7 o'clock. Okay?
That's why I moved from Regan.
Yeah. You got that? Yeah? So, (10 a.m. minus 2:30 a.m.). What's that? 6.5?
Yeah.
6.5, isn't it? No,
7.
7.5. Okay, fine. 7 a.m. minus 1 a.m. equals 6. Okay. So 1.5 over 6 is about 16%. Okay, so you slept 16% more. Okay? So, I'm tired. Right.
Okay.
Next. So what would be the units here for E? The units.
E.
Yeah, what would be the units? What are the units here?
I guess.
Yeah.
John.
Newton per
Yep.
coulomb.
Newton per coulomb. Yeah. Now, maybe you can write this as something else, okay? Because look, before you go continuing, all right? Newton per coulomb. Well, we said F equals ma.
Oh.
So 1 Newton equals 1 kilogram meter per second squared. So you could write this as 1 kilogram meter per second squared, and coulomb is still coulomb. But could we simplify this anymore?
No.
Don't know.
Something joule.
Joules.
I don't know.
Oh, I know what you mean. Something joules. I don't know. Newton per coulomb will be
Okay.
fine. Okay. Right, you got that?
Yes.
Okay, so here's an example. A current is running through a copper wire and it makes an electric field. And this is how strong the electric field is. What is the force on an electron? Okay, so I'll just draw this here. You have a current and it makes an electric field. And here you have an electron. And the electric field strength is 10 to the minus 25 newtons per coulomb. Okay, so what will happen is this will be pulled towards the current. My question is, what is the force? So you only have one formula for today. Can you calculate the F? Yeah. Yep.
Long time did they use calculator?
Do you not use it in maths?
Do they?
Good English, not bad English. Should get an answer. What? You don't want to use your calculator. What you get, Ben?
What is the Q?
The Q is an electron.
Minus.
Oh. Is 1.602 times 44, I think.
You are right.
I don't
No, you don't. You don't need a calculator.
Just
Yeah.
Oh.
Look. You use this formula, okay? So F equals EQ. There's the Q.
Yeah, just cancel.
Yeah. You didn't sleep enough, huh? All right, continue. An electron is placed from 3 protons, and the electric field strength is 1.41 times 10 to the minus 24. What is the acceleration of the electron? So look, I'll draw it for you. You have proton, 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 electron. And the electron will be moved towards the proton. And the electric field strength is 1.41 times 10 to the minus 24 newtons per coulomb. And my question is, what is the acceleration? A.
acceleration.
A, yeah.
Earth.
Acceleration. ACC, yeah.
Yes.
It's getting faster.
No.
No, same formula.
Same one?
Yeah.
This acceleration. Oh, am I?
Sorry, 24, Ben. 24. Yeah.
Is minus?
I don't worry too much about plus or minus. We'll just say that's plus and that's minus.
Okay.
So, yeah, let's see. So you have E equals F over Q. But F equals MA. So E equals MA over Q. So A equals EQ over M. So that's equal to 1.41 times 10 to the minus 24 times 1.6, is it?
60210.
Yeah,
It's 10 raised to power minus 11.
9 or 19.
19,
Minus
19,
19.
19.
Now, question. What mass? Is it the electron or the protons?
What
Electrons.
else?
Electrons.
Electrons.
Yeah. Which is 9.11 times 10 to the...
Minus
Minus 31.
31.
Okay, so what answer did you get, Go? Or Ben?
2.8
Yeah.
and power of minus 75.
75?
I don't know, like, I don't understand the show, like E.
Actually, you need a bracket.
Yeah, what did you get, Ben?
2. Excuse me.
2.48 minus 13. That seems right.
13.
This, just bracket this.
3.47
Oh. 0.
Yeah.
English. What did you say?
Is there a bracket? I mean,
Yeah, so you can say it in English. Okay. Right. Okay. A small dust particle of mass 1 milligram and charge of minus 100 electrons is placed between two horizontal plates. The place produces an electric field. The small charge is held balanced. How strong is the field? So this is what you have, okay? You have a plate, you have a small negative charge. It's minus 100 E, and its mass is 1 milligram. Gram, like kilogram, okay? Now, this plate here is positive, and this plate here is negative. So you have a field here. And what happens is this gets pulled up with a force. And this balances this force. What's this force? The weight. So they're balanced. Okay? And my question for you is, what's the E? Okay.
what's mean minus 100 E?
That's its charge.
Electron.
Yeah? Give it a try. Now, before you start, you should figure out that is 10 to minus what kilograms?
Millikilogram.
Milligram.
6.
Good. Get an answer, Ben? So let's have a look. Look.
Or the same answer.
Maybe you're both wrong. So let's have a look here. We have F equals QE, but also F equals mg, because, you know, they're the same. So that means QE equals mg. So E is mg over Q,
Yes.
which is 10 to the minus 6 times 9.81 over 100 times 1.602 times 10 to the minus 19. And what did you get?
6.12 times
11. 12.
yeah 11
The unit?
Newton.
okay Newton.
Yeah, okay. So this question is just a bit silly, but my question is, you have a proton here, you have another proton here, and this distance here is r. And imagine you move this one closer so it's here. So that's a half r. What happens to the electric field strength? Well, the formula is it's F over Q. So do we think the E will be bigger or smaller? It'll be bigger, won't it? Yeah, it'll be a bigger. But which part is bigger here, the F or the Q? The F is bigger. Yeah. So the F is bigger. So the E is bigger. It's a silly question. It's obviously bigger. We talked about this earlier. It's fine. Yeah. Okay. So let's see. How are we doing for time? Good. Good. How many questions? Not too many. Did I give you for the first lesson? Huh?
5 yes
5 to 9.
Uh, 5 to 9, yeah. Can you try them now? And I'll tell you, number 8 is a nice question. It's nice and
nice
interesting.